Alright, after we learned about z-test, then we can discuss this hypothesis testing with z-test. In other words, we're going to step by step follow this hypothesis testing using the z-test to analyze the data. Okay. First is the study overview. This is what I will give you. Okay. Providing all the information for this hypothesis testing. So we asked the participants their opinions about abortion, right? The question is, from 1 to 9, how much do you agree with the legalizing abortion? Now, we gave the data from 400 women in general psychology classes or whatever. Now, the histogram of the data suggests the distribution is approximately normal. Now, we give them a survey to fill it out individually, anonymously, so ensure the independence. Now, the assumption of a homogeneity of variance is met. Okay. Now, the purpose of this survey is to see if there's a gender difference on the issue of abortion. We believe, because from research evidence, that women will be more likely to agree than men on legalizing abortion. Now, suppose we already know opinion of a male population, mu is 5.61 and sigma is 1.95. And the data for the woman sample, mean is a 6.45, standard deviation 1.02. All right, so first is the assumption. We need to review the assumptions if this research met all the conditions, right? Now, the first one, interval or ratio scale of measurement is met. Yes, it's met because the question is, hey, from 1 to 9, how much do you, this is a Likert type scale. The second assumption, participants are randomly selected, not met. You just need to say not met, therefore we must be cautious when generalizing the result. Normal distribution is met because based on the histogram, it's approximately normal. Remember? Independence met. We just say that. And then population variances are equal. Homogeneity, right, is met. So we can move on to the next step. Now, hypothesis and alpha. First, we determine alpha level to be 0.05. Yeah, that's the case. Now, we believe it's directional because as we said, the research evidence suggests that women are more likely to agree. So we already believe women will be with a higher mean. So therefore, we use a one-tailed test that is directional. So the critical value is 1.65. It's a little bit lenient, right? Remember? Now, research hypothesis. Women will agree with a pro-choice significantly more than men do. And this is the symbol. So H1, mu1 bigger than mu2. The null hypothesis will be women agree with a pro-choice equally or less than men do. This is a null hypothesis, right? It's a mu1 less or equal mu2. Now, step 3, specifying the test statistics. Now, because we have only one sample and the other one is the population, and we know population means standard deviation, so we use a z-test. Now, computing the test statistics, just follow the formula. So, population mean is 5.61, population standard deviation 1.95, sample mean 6.45, sample size 400. So, follow this formula, and actually we calculated already. I didn't show the step right here, but when you do the report or in the exam, you must show all the steps. Okay, otherwise you get no point. And then finally, decision and interpretation. So because 8.4 is much higher than the critical value 1.65, because it's a one-tailed test, right? So in other words, it's in the critical region. In other words, p less than 0.05. So we reject the null hypothesis. Now this is a decision. Now, interpretation. The results suggest that women agree with the pro-choice significantly more than men do. All right. Up to this point, I hope it's clear enough. If not clear enough, please email me. Let me know. Okay. There will be homeworks or practice based on this. Okay. Okay.